Okay, so second lesson, really important. So let me just try to make a little bit of connection to what just took place. So far we looked at two basic forms of the quadratic. The most basic of forms, y equals ax squared. We all know that A tells you whether it's a max or min. Positive A is a min, it opens up. Negative A is a max, it opens down. The absolute value of A tells you whether it's relatively wide or flatter, or whether it's relatively narrow or steeper. You know all that. We also know in this form there is no H value, and that's 0, and there is no K value, and that's 0, and so our vertex is 0, 0. We also know in this form that our line of symmetry is always x equals 0. From there, we could go on, and we did yesterday, day before, and we had a K. So that was the second form. Therefore, then K went here. The vertex is 0K. And the line of symmetry is still x equals 0. A still controls whether it's a max or min, and the relatively width, whether it's relatively wide or relatively narrow. All that's the same. You got to know those two formats. You got to be able to look at functions in those two formats like the chart we just did and be able to tell me all the different stuff. Is it a max? Is it a min? Does it open up? Does it open down? What are the coordinates of the vertex? What's the line of symmetry? Is this thing relatively steep or narrow, or is it relatively flat or wide? You tell me all of that stuff from both of those forms, and that'll happen tomorrow. In addition, now we'll get to the full-fledged form. This is the graphing form for quadratic functions. A is still A. A tells you whether it's a max or a min, tells you relative width, etc. What are the vertex coordinates? They are HK, and I think we're going to list all that. No, let's do it right here. So the vertex has coordinates of H. Oops, wanted that to be red. Great. Let's do it this way. Of H and K. So now the x coordinate of the vertex is no longer 0. And so what we are now doing is we have a horizontal shift. I want that to be red. So Tuesday we did the vertical shift, that's the K. K shifts it vertically, H shifts it horizontally, right? And so that's a translation, we learned that word, and so the vertex or the whole parabola is translated according to the value of H. So the value of H is going to control the horizontal shift. In the other two formats, the value of H would have been 0, right? It didn't go left or right from it didn't go left or right from the origin. K moved it up or down, but H moves it left or right. So again, in both of these formats here, the x was 0. We could have written this if we wanted to, but it would be boring. We could have written it like that. Oops, like that. But that's boring, right? Why would we stick a 0 in there? It's the exact same thing. Isn't that ax squared plus k? It is. Okay? So now let's look at the h and how it affects. So what you've got there is the graphing of y equals 1/2 x squared. And that's the blue parabola. It's graphed there for you. So vertex was 0, 0, and you can see it's there. And I did an XY chart the rest of the way, and there it is. Okay, so looking at this parabola, so I already know the vertex, right? The vertex is going to be what? 2, 0. Because the h value is 2, and the k value is 0. And we've been through this before. Remember, you're reading the h value after a minus sign. The minus is in black, the h is in red. So x minus the value of h, which is 2. This thing is moved 2 to the right. Now, this one's harder to think of than the vertical shift. The vertical shift is easy. No matter what output you got, all of a sudden the amount of the vertical shift moves it that much higher if it's positive or that much lower if it's negative. You tack it on to the end. The horizontal shift's a little bit trickier. So the thought here is, okay, here, let me just circle it. When I input a 0 here, I output a 0. But now, when I input 2 more, I output that same 0. When I input 2 more, I output that same 0. So again, we have the point 2, 0, and we already know that's the vertex. Back on the blue one, when we inputted a 2, we outputted a 2. Now we got to input a 4, 2 more, to output that same 2. So when I input a 4, I output a 2. And on the left, when I inputted a 4, I outputted an 8. Now, with a horizontal shift, I have to input a 6, 2 more, to get that same output of 8. 1, 2, 3, 4, 5, 6, 7, 8, right there. And again, I'm going to use my line of symmetry here and finish out the points. 2 right, 2 left, 4 right, 1, 2, 3, 4, 4 left. And you can see the parabola has shifted to the right by 2. It's an ugly U, but it is what it is. Did it get any steeper, any wider? No, because the A is a half in both of them. Did it flip from a max to a min? No, because the A is positive in both. It was a min and it still is a min. The only difference is we moved it 2 places to the right. Because now it takes 2 more of a value of x to get that same output of y. Again, that's a little hard to understand brain-wise, but that's what's going on. So every input is increased by 2 to get that same output. That's what's going on. That's the way it works. That's going to work when you do a circle. It's going to work when you do an ellipse. It's going to work that way when you do everything. All right, so I guess here's where I finally come down and put in H and K for you. You got to know that. I'm going to give you functions, and you're going to tell me whether it's what's the vertex, et cetera, et cetera. Oh, by the way, I hope you tomorrow can tell me whether something is a linear equation, linear function, quadratic equation, quadratic function, polynomial equation, or polynomial function, because I'm definitely going to ask you. And I hope you can tell me by looking at the quote-unquote equation. All right, so pretty simplistic on the first one. Give the coordinates of the vertex. It's color-coded, all right? I think you can tell me it's 4, 7. Nothing mysterious there, right? It's in the right form. We're just reading H and K. Second scenario, oh no, no color. But hopefully we still say the H is, and the K is -5, right? 1, -5. 1, -5. So therefore, this third one, which by the way, it's a max. It opens down, relatively narrow. And the coordinates of the vertex are? -2, 1, right? -2, 1. And lest some of you don't quite understand, let me put it in proper form for you. That must have been minus a -2, right? Because again, you read the H value after a minus sign. But they're not going to write it minus a minus 2 because that's not proper format. Okay, so real quick, do the last example there. Give me the vertex coordinates of that last example. And everybody says -7, -6, right? Because everybody surely moved that 8 to the other side by adding its opposite both sides, right? Surely you did, because it's not ready to read anything yet until you put it in the right form. And hopefully that makes sense to you. Okay, so now the axis of symmetry, also called the line of symmetry, it's no longer going to be x equals 0. Now it's going to be x equal h, right? Which is simply the x coordinate of the vertex. Now, my time is very, very limited, so I just want to take a quick second for those of you that can handle it. I want you to look right here. Don't write this. I just want to show you something for those of you who can handle it. What if I wrote x equals a times the quantity, y minus quantity squared? What do you think what letter would I put in there with the y? What would you think? Look, here's the difference. Y equals a times quantity x minus h plus k, quantity squared plus k. Now the x is out here all by itself. The y is squared. So what letter's going in there, h or k? Hopefully k makes sense to you because k is the vertical one with the y. And therefore on the outside it must be, right, plus h. How would this parabola go? If a were positive, how would this parabola open? Up, down, left, or right? To the right, right? Heading toward the positive x values. And if it were a negative a, it would open up left, pointing to the negative, well, I have to do it backwards, right? Negative x values. All right. So anyhow, there are left-right parabolas as well. And if you want to spin it at an angle, you got to use trig functions, sine, cosine, tangents, to spin it at an angle. That's all advanced math. I don't get to have that fun, unfortunately. Okay, so line of symmetry is x equal h. In the one I just showed you, if it's going this way, what would the line of symmetry be? Y equals k, right? Because the line of symmetry now is a horizontal line, which is a y equal. R's are vertical right now, x equal. Okay, state if it's a max or min, if it opens down or up, vertex coordinates, the shifts, the line of symmetry, and the relative width. All right, piece of cake. I'm going to go fast because my time is flying by already. Max or min? Max, it's a -8/5. Vertex coordinates, say it if you know it. -3, -11. Oh, I didn't say open up or down yet. Max is open which way? Down. What's the shift? 3 to the left and 11 down, right? 3 left, -3 is left, +3 would be right, -11 is down, +11 would be up. Line of symmetry, x equal -3, the x value. Is this thing relatively wide or relatively narrow? Narrow. Any value 1 or greater of the absolute value is narrow. 8/5 is bigger than 1. All right? Narrow, or in the book's term, steeper, at least the book now. Okay, B. Is this a max or a min? Min, right? Does it open up or down? Up. What are the vertex coordinates? 3/2, 6. So this thing is moved which way? Right. How much? 3/2 or 1.5, however you want to say it. And 6 up. What's the line of symmetry? X equals 3/2 or x equal 1.5. Is this thing relatively narrow or relatively wide? Greater than or equal to 1, we technically call narrow. Again, your book now is stuck in the same steeper, flatter idea, which is a new concept. You know, again, maybe a Common Core thing, who knows, but We used to just go narrow or steeper. Okay, next page. This better be the last page, or I got a really motor. Oh, I got a motor. All right, here we go. State of as a max or min, the vertex coordinates, line of symmetry, and then graph it. Okay, I'm trying to set you guys up with how to graph these. And the way you graph it is you've got to start out with figuring out, is this thing a max or a min? Give the vertex coordinates. So you look at this and you say it's a min, positive 2, a positive A. And you say the midpoint coordinates are 1, negative 3. You must start here. You must plot this first. This is what gets you going. So I'm going to go on my coordinate plane. I'm going to go 1 to the right and 3 down, and I'm going to plot my vertex. You want to do that first. Will everybody do that first? No, all the dumb ones won't. And not dumb because they're not capable. Probably dumb because they didn't review and studied and remembered that that's what they're supposed to do first. I'm just telling you, you're going to get all goofed up if you don't do that first. You're going to wonder why the points are in the place they are, what's going on, and you're going to get all goofed up. You've got to do that first. Line of symmetry, because it opens up, would you agree, is right there? I don't need to say it's x equal 1. I can if I want, but I know it's there, right? No, it's opening up. That's my line of symmetry. Destiny, you're going to need to stand up? Or are you okay? You're good? Okay. Look, I'm already at 1 on the x. So I'm going to go 2 as my first point, right? I'm already at 1. I'm going to go 2. And again, where the x is, I'm putting that 2 in, right? Doing the parentheses first. 2 minus 1 is 1. 1 squared is 1. 1 times 2 is 2. 2 minus 3 is a negative 1. I have the point 2, negative 1. So line of symmetry, I also have what point? 0, negative 1, right? Line of symmetry. From 1 to the right from line of symmetry, I got a point 1 to the left. All right, I'm going to go 3. So again, where the x is, I'm going to put 3 in. 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 3 is 5. 0.35. 3 to the right, 5 up. 1, 2, 3, 4, 5. 5 up is 2 to the right. I'll go 2 to the left from the line of symmetry. Have I pretty much covered the Cartesian plane? Sounds good to me. I'm drawing my parabola. Voila, we are there. You guys did domain and ranges last night, so I'm just going to stick in all the real numbers. And the range would have been what? Y greater than or equal to negative 3. And I don't have time to do intervals. Okay, so that's the idea. So second one. Remember, you're going to first off state this thing's a max. I know it's going to open down. Max coordinates. You're looking at yours, right? You're thinking, right? Not just mindlessly writing what I say. So hopefully you're thinking negative 1, 2. Again, whatever the stuff says there. And I'm going to plot this first. So I'm going to go negative 1. So 1 left and 2 up. And this is my starting point. Because I know it opens down, I'm going to put my line of symmetry going down from that point. Great time saver. It's going to give me points on each side of the line. So what's the first x coordinate I might want to use? Now there's 2 things involved. Where I'm starting from and this 2 on the bottom. So what's a great x coordinate to use first? Not 2. Not 4. I'm at negative 1. I want to go 2 away. So I'm going to use 1. Bottom denominator of 2, I'm going to go 2 away from where I am. Watch what happens. Negative 3 halves, put a 2 in for the x. Put a 1 in for the x, thank you. All right, we're using 1. 1 and 1 is 2. 2 squared is 4. 4 divided by 2 is 2. 2 times a negative 3 is a negative 6. Negative 6 and a positive 2 is a negative 4. And I have the point 1, negative 4. Wow, I'm already down there. But remember, this thing is relatively narrow, isn't it? Relatively narrow. All right, for time's sake, 3 would give you a negative 22, which is fine. Look, here is the 3 on that line, right? So I know I'm like way down here, so I'm just heading towards it. Look, just watch for a second. Just watch. Don't draw anything. Would you agree I wouldn't do this? That would be wrong. Because I know at this 3, I'm down here, right? So, I mean, even though I can't plot the point, it does give me some direction for where I'm going, right? And I just do the same thing the other side. And there's my parabola. And away we go. Destiny, what time did you go to bed last night? Do you need vitamins? Do you have iron, poor blood or something? Okay, real quick. Complete the square. We've done this already. Because you know what? This isn't in graphing form, is it? And we want that vertex, and the vertex is the holy grail. I'm telling you. Later on, we're going to do word problems. You know what the vertex tells us? Everything. 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 So we want to complete the square so we can put it in the right form. Okay, nothing to factor out, thankfully. But I would if I had to. You remember you take the b, divide it by 2, and square it, yes? If not, you better go back and review. 6 divided by 2 is 3. 3 squared is 9. I put a positive 9 in there. Therefore, what do I do on the outside? If I put a positive 9 in, I put a negative 9 out. You got to keep it balanced. I can't just stick 9 and not change the value. Let's finish completing the square. Square root of the front, sine of the middle, square root of the back, quantity squared. Positive 7, negative 9 is a negative 2. Do you now know your vertex? You do. It is at 3, negative 2. You know this thing is a min. You know it opens up. You're going to plot that point first. 3 to the right, 2 down. There's my vertex. How are you going to finish it? XY chart. And again, your line of symmetry is right there, right? I'm not going to finish it because I need to give you one last piece of information. Okay. This is standard form, right? ax squared plus bx plus c. Only in this case, y equals it. Because it's not of an equation, it's of a function. And we could complete the square. We just did that a minute ago, right? To get it in the correct form. There is a shortcut. I don't know how you're going to remember it. I'm not going to develop it. I would have. The book develops it. So let me skip right down to the bottom line. Off of standard form, you can write the coordinates of the vertex. They are negative b over 2a. You know what b is, right? You know what a is, right? The h coordinate is negative b over 2a from standard form. And guess what? The k is a little tricky. It's c minus b squared over 4a. I know it's kind of weird, but that's what it is. So this is the h value of the vertex, and this is the k value of the vertex. So if you can remember that, and all you need is the coordinates of the vertex, you could do a shortcut off of standard form. Or you could just complete the square and read it, right? I'm kind of a complete the square and read it person. And that's what I wanted you to do in this last example. Without completing the square, give the coordinates of the vertex. I'll give them to you, so in case you want to try to figure it out yourself, you should have ended up at 2, 3. You should have ended up at 2, 3. So if you would do negative b over 2a, you should get 2. If you do c minus b squared over 4a, you should get 3. Quiz tomorrow. You see your homework down there. Quiz tomorrow. Quiz tomorrow. You can't take days off, okay? You got to work.